This is the first mini lecture for section 2.1 of the textbook. It corresponds to section 1.1 of the syllabus. This section is about sets and operations on sets. The goal of the course is to understand basic arithmetic. We want to study things like addition and subtraction and multiplication and really understand how they work. Before we can talk about those things, though, we need to understand counting. Now think about counting when you first encounter it in school. You're always counting things. You begin learning how to count by counting objects. So really, before we talk about counting, we have to spend a little bit of time talking about objects themselves. So that's the goal of this section, is to understand groups of objects. It's going to be a little bit abstract and a little bit unfamiliar to you. This is the part of the course that includes material you probably have never seen before, but it's also very useful. So we want to understand how counting works. We begin to learn to count by counting groups of objects. First, we need to understand groups of objects. A set is a group of objects. Each object that belongs to a set is called an element of the set. So those are two words that are important for you to know: set and element. The set is the group. The element is an object belonging to that group. When you define a set, two things are typically required. First, there has to be a universe, or a big background set, that contains everything under discussion. What kind of objects are you talking about? Are you talking about the numbers 1 through 100? Are you talking about all the numbers, or all the whole numbers, or all the fractions? Are you talking about all the people in the world, or all the people at our college, or what? Just what's the general background? And second, each element of that universe has to either belong or not belong to that set. There is no gray area. If A is a set and X is an element of A, then we write X as an element of A using that funny looking symbol. It looks kind of like an E. If X is not an element of A, then we just write X as not an element of A by putting a slash through that symbol. Okay, so that's how we use the notation. There are three ways of describing a set. On this slide, we're going to describe the same set in three different ways. The first is the word description. Let A be the set of cities containing an RGC campus. So A is that set of cities that we just described. Now, we can also describe that set by just listing the elements. So these are the objects that satisfy the rule for belonging to the set. Namely, they are the cities that have an RGC campus. So A contains Del Rio, Eagle Pass, and Uvalde. We just list the elements separated with commas inside of these little curly braces. Braces like this. But when you do this, the order doesn't matter. It also doesn't matter if you repeat things. So for example, if I said A is a set containing Eagle Pass, Del Rio, Uvalde, and Eagle Pass, that's the same set. We just care about what's in there, not about the order or the repetition. Okay, the third way of describing a set is something we won't use quite as much in this course, but the book uses it off and on. It's called set builder notation. So this would be read as A is equal to the set of all X, such that X is a city containing an RGC campus. Again, A is the set of all X, such that X is a city containing an RGC campus. You can think of this little bar as representing the such that. So for example, we could say Del Rio is an element of A, or we could say Quemado is not an element of A. we can use Venn diagrams to illustrate sets. For example, let's let U be the set of numbers from 1 through 25. That's going to be our universe. Let A be the set of elements of U that are odd, and let's let B be the set of elements of U that are multiples of 3. So first let me write out what A and B are, and then I'll draw a picture to illustrate this. So A is the set of elements that are odd. So A contains 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, and 25. Incidentally, you can find these slides on Blackboard. I would recommend that you print them out if that's possible for you. If it's not, I would recommend maybe pausing between each slide and just copying down what the slide says. Either way, make sure to complete it with the stuff that I write down. Okay, so that's the set A. The set B is the multiples of 3. So it's going to be 3, 6, 9, 12, 15, 18, 21, and 24. Okay, and then U of the universe, that's 1 through 25. That contains both of those. And as I look at these two sets, I notice that while they have some things in common, like the number 9, of course they have plenty of things that they don't have in common. And then, there's plenty of elements in U that are not in either of these, like the number 2. So we want to draw a picture to illustrate all of those relationships. I'm going to begin by drawing two big loops. They're going to represent our sets A and B. So here's A. Here's B. And I need a box around them both because we have this universe in the background that contains both of them. Okay, so now I just go through each of the elements of U, all 25 of them, and I locate each of them in the appropriate region. Notice that there's 4 regions here. There's the outside, there's the stuff that is just in A, the stuff that's just in B, and the stuff that's in the overlap. Okay, so let's see, with the number 1, that is in A but not B. The number 2 is in neither, so that's floating outside. 3 is in both. 4 is neither. 5 is just A. 6 is just B. 7 is A. 8 is neither. 9 is both. 10 is neither. 11 is just A. 12 is just B. 13 is just A. 14 is neither. 15 is in both. 16 is neither. 17 is just A. 18 is just B. 19 is just A. 20 is neither. 21 is both. 22 is neither. 23 is just A. 24 is just B. And 25 is just A. And so now using this Venn diagram, we can tell at a glance what the two sets share, what they don't share, what is just in A, what's just in B. what belongs to neither. We can tell all of that just at a glance. Okay, and Venn diagrams can be used in different ways. A good example of that can be found at the end of the homework for this section on page 78. Here we're supposed to be using Venn diagrams to illustrate students that like hamburgers, pizza, and or hot dogs. Students could like just hamburgers, just pizza, just hot dogs, maybe both hamburgers and pizza but not hot dogs, maybe all three, and so on and so forth.